Oh,
Okay.
recording in progress.
Got it.
I think we've started. I don't know.
Yes, there's more than 3 of us. So yeah, we have started.
I'm loving John's t-shirt, by the way.
What's he got on today?
I'm hoping it's Star Trek Deep Space Nine.
Yeah,
it isn't. It's not.
No, it's an Enterprise one, isn't it?
Yep.
Yeah.
Do you remember them 10 points? Minus a couple, JW.
All right, so we've got, where's my
Oh, do you know what? Today,
participants?
what a long day.
I've got a long day tomorrow. I've got to drive down to Derby. I've got to be at Derby for 7 a.m. Oh,
Nice. How do we know people are in here again? I can never
there
remember
are,
this.
right, if you click, right, click participants on the Zoom, and then you'll see there are 20, 21, it's climbing up, and then it pops open, and then you can see panelists, and then there's attendees.
Oh, yeah, I can see
there.
it, yeah.
And they're talking in the chat. Mr. Bickerton has already said, good evening.
Let's get on with this. Brilliant. Okay. Hello, everybody. Welcome to this year's webinar series, I suppose. So we thought we'd start at the beginning, in the very first edition. So today, we're going to talk a little bit about the history of the wiring rules. Now, if everybody likes this and people watching on YouTube like this, then we may be tempted to do some summary ones on the 2nd, 3rd, 4th, 5th, etc., depending on people's thirst for knowledge here and in the wonderful world of YouTube.
And we can kind of highlight along the journey where the key changes shifted, where the key of, the key mentalities, the key, changes in direction of some of it came in.
Indeed. I'm just going to check my computer actually works and my screen moves. There we go.
No worries.
Okay, it does work. Okay, right. So this is called the history of wiring rules. Although the first thing we need to start off is this is only going to be the first edition because when this was first researched, I was doing IET lectures where we were kind of taking people on a journey all the way from the 1st to the 18th edition, which was being released. And the feedback was more people wanted to know more about the first. And I thought, okay, well, maybe one day we'll do something. So here we are. First little key fact, because this isn't going to be a 3-hour webinar, and I'm sure Dave will, as the operator of the question and answers, Dave can then just chuck some polls to see what people think. First thing you need to know, there's been 49 printed editions of the rules and regulations published. How many do you own, John Ward?
28. So not all of them, but more than half anyway. So getting there. So
shame and disgrace upon you. So there you go. So John's got 28 of the 49. He's doing well. And if anybody has any copies that he doesn't have, I'm sure he'll be willing to recycle them accordingly. So yeah, first bit of information, 49 printed editions. But before we get into all the editions and all the rest of it, we need to go back to the very, very beginning. Okay. And in the very beginning, 1847, to be clear, there was an act from Parliament called the Town Improvement Clauses Act. And that was that document on the left. And it was basically known as the Gas Act, because before electricity, we had street lighting, which was very common, and it was all done via gas. And so what they were trying to do was to set prices of gas, resolve land disputes for all gas distribution and various other, trying to clean up communities and all that back in 1847. But as is always the way, it's never good enough. But that Gas Act does have some grounding in what we know today, and we'll take you through where and how and why. But moving on from that date, 17th of May, 1871, that bloke in the corner called Sir Charles William Siemens. Everybody nowadays knows Siemens. They're mass producers of AFDDs, RCDs, and large industrial commercial equipment, and they're massive. They own Electrium brand and own Wilex. And
I'm going to say we're a lot more familiar with as electricians as their one of their brands down the line, Electrium through to Wilex and Bolex and
Appleby,
yeah,
and Crabtree.
So,
Sir Charles William Siemens, he was born in Germany, but he actually lived in London and died in England. He was actually the very first president of the Society of Telegraph Engineers, which we'll get onto in a minute. But he basically founded the Society of Telegraph Engineers, which obviously later on, because maybe the telegraph engineers didn't know how to party, they got all the electricians in and it became telegraph engineers and electricians. But what this guy was famous for, please note the all expense spared light bulb, a place called Godalming town in September 1881. It was the first town in the world to have a public electricity supply installed. And it was a company called Calder and Barrett who installed it. And they used a Siemens AC alternator and dynamo. i.e. motor, which was powered by a water wheel at Westbrook Mill on the River Way. I can never pronounce that correctly. There was a number of supply cables. A lot of them were laid into gutters, and there was several arc lights and 34 incandescent lights. So basically, floods caused a lot of problems, and basically people rebelled against this horrific electrical lighting. And then in 1884, they went back to gas. So the very first mass application of electricity rejected by the masses, which is ironic beyond belief.
But again, back then, this was really just what alternative to lights, and what other power use was there then? You know,
It wasn't.
So, you know, a lot of people probably didn't see the need for it. Yeah,
it's rich and famous, I think it's fair to say. Obviously, moving on, 1872, the Society of Telegraph Engineers turned up. Obviously, Sir William Charles Siemens was the president, the first initial president, and then moving on in 1875, I'm going to take us back to the law. This document showed up, which was called the Public Health Act. And that was purely designed to clean up streets and communities, because you can imagine back in them days when you went to the toilet, you just probably chucked the bucket out the window, and it didn't keep communities healthy and clean, and the government realized they had to do something about hygiene. Now, if anybody wants a copy of any of this stuff here, it's all available on the UK government website. Believe it or not, legislation.gov.uk, these documents are still available in PDF. Okay, so they're not hidden away in a library anywhere. These are available. As you can see, it talked about execution of the Act, sanitary provisions, etc. Now, this document was really important in 1875 because it led to a further development and a further act. And that was in 1882, the Electric Lighting Clauses Act, which I want you to remember the date, 1882. Sound familiar? Yes, it does. So this is an act of parliament, okay? But let's just go back 2 years, because 2 years before that document came out, the Society of Telegraph Engineers and Electricians got together. And what they did do in that year was on May the 11th, 1882, 2 years later, they produced the rules and regulations for the prevention of fire risks arising from electric lighting. Now, we know it as the first edition because that's what the IET call it, but the title is so prevalent, it's mind-blowing. Rules and regs. I'd like to probably know a little bit more about how people interpret the definition of rules and regs. Maybe, Dave, you can run a poll, what people think rules and regulations actually are and the difference between them. Because to me, regulations is laws.
Well, actually, a poll is kind of like a question, yes or no kind of thing. But I mean, you guys in the chat, just throw in what you think the difference is between rules and regulations, and we can read out some of your answers.
And the most interesting part of the title, because it is so relevant today, prevention of fire risk, still relevant today, 130 plus years later, still relevant, which is mind-blowing. So yes, that was the first edition. That's what it looked like. That is a scan of the very first original, and what happened in them days. I'll set the scene a little bit. Back in the early days of the society, what they used to do was produce something called white papers. And it was a means and method of documenting technical developments, engineering mindsets, thoughts, research and analysis. And they would get together as part of the society and present these papers. Now you can go online and buy the journals of the entire Society of Telegraph Engineers and Electricians, and you will see the early thoughts and debates on earthing and lighting and electrical safety, and you can see where all of the rules that we have nowadays, where they've come from. But this was the first copy. As you can see, it's not very clear. It was basically a little fold-out paper that was handed out to the guys as they entered the building, which was not the IET in London. It's actually a different building in London at that time. And it was divided into 4 parts: the Dynamo Machine, the wires, lamps, danger to person. Dave, how many parts do we have in ours now?
Well, 7, and it's about to grow.
Yeah, about to grow. So we're nearly doubling that nowadays. So a couple of bits before we start. There is a bit of a preamble. John, do you want to start with the preamble?
Yeah, we can. It's in the beginning, there was a lot of fire, smoke coming out the bottom.
That's to a dramatic effect, sorry.
Yeah. These rules and regulations are drawn up not only for the guidance and instruction of those who have electric lighting apparatus installed on their premises, but for the reduction to a minimum of those risks of fire which are inherent to every system of artificial illumination. I'll do this one as well. Yeah,
Go on,
the chief dangers of every new application of electricity arise mainly from ignorance and inexperience on the part of those who supply and fit up the requisite plant.
See, I like this because having ignorance and experience identifies that there was probably a lack of education, training, and all sorts at the beginning. And a lot of the work was carried out by persons. I mean, if you're doing things for the first time, it's hard to gain experience anyway.
Yeah, and this is the thing. This is the interesting thing. So somewhere in this mess, I actually have a printed copy of that first set of white papers. It's fascinating when you just dip in and sample the debate around what we now know was being questioned and thought about and assumed, and people trying to come up with basically formulas to prove the theories, which is now what we take for granted. But yeah, that experience was being consciously developed. It wasn't available off the shelf. So the inherent dangers from electricity in these days was off the charts.
And again, there's a big difference between scientists, getting dynamos, creating electricity, doing some small scale transmission, and then trying to distribute that up to a larger scale.
Indeed.
There's going to be lots of learning, hence the fire risk was probably in reflection of a lot of experience to that risk.
It is one of the chief fire risks, other than these two blokes here getting trapped in machines and falling down holes.
Yeah, and the thing at the time was that, of course, there was no national grid, so you didn't just call up somebody and get electricity installed. You wanted electricity, you had to get your own equipment put in, your own generators, your own everything, because there was no one person to buy it from. It was literally do it yourself. And if you didn't do it yourself, you got absolutely nothing, because there was no other choice.
And this is why this preamble continues. Would you like to eloquently continue, John?
Yeah, the difficulties that beset the electrical engineer are chiefly internal and invisible, and they can only be effectually guarded against by testing or probing with electric currents. They depend chiefly on leakage, undue resistance in the conductor, and bad joints, which lead to waste of energy and the production of heat.
So hang on a minute. So in the preamble to the regs book, we have got the words internal invisible, which talks about the internal learning struggle to me, but then it talks about testing, probing, leakage, resistance, joints, waste of energy, energy efficiency, and heat, thermal effects, in the preamble to the very first book. So in these early days of experiments, I remember, Dave, you remember when the 18th edition was coming out and there was all the, we're going to have an energy efficiency section 8, and everyone was like, no, we can't do that.
Well, they said it had nothing to do with BS 7671. Energy efficiency had nothing to do with the fundamental principles, but it's built on this.
It's built in the first edition. Yeah. Waste has always been a consideration, which is mind-blowing. Right, let's just see why my computer's froze. There we go. Right. Carry on, boys. Read away.
Can we do this one?
Yeah, go for it.
Yeah.
Okay, so these defects can only be detected by measuring by means of special apparatus. The currents that are either ordinarily or for the purpose of testing pass through the circuit. Bare or exposed conductors should always be within visual inspection, since the accidental falling onto or the thoughtless placing of other conducting bodies upon such conductors might lead to short-circuiting or the sudden generation of heat due to a powerful current of electricity in conductors that are too small to carry it.
So short-circuiting,
short-circuiting,
powerful current, sizing of conductors, again, visual inspection. It's just one big warning, isn't it?
Mm-hmm. I just love that, I love the words chiefly and things like that. I'm going to write a book just so I can use these words.
Go on to the next one. Go on, Dave.
All right. It cannot be too strongly urged that amongst the chief enemies to be guarded against are the presence of moisture and use of earth as part of the circuit.
That in itself is mind-blowing. The fact that we considered earth as an enemy is amazing, because in that days the context was, if your circuit comes to earth, it's a hazard to the circuit, whereas we now use earth as a protective measure. But a little bit of history for you, and I've got some of the white papers on it. There is lots of fascinating debates on earth, and the reason that little image is in there is because when people were looking at earthing, they was assuming the electromagnetic fields of the earth would cause chaos with the development of energy and electricity and how it's controlled and managed. And there's some absolutely mental debates on electromagnetic fields of the earth, because they genuinely, some people are of the view of you can take the energy from the earth, which, you know, as you're developing and understanding, these white papers are a minefield. I got lost in them for months while I was going through it. They literally, one paper I remember talked about gravity in relation to the earth and the positive and negative flow of electricity, which again, I still remember, and it was months ago I read it. But yeah, so Earth is the enemy, apparently, according to the first edition. Might be probably one of the few errors, but yeah, I can see where they were getting.
Well, it probably wasn't an error at the time, because again, it wasn't, if you had an extra installation in your house, that was it, and it wasn't connected to anyone else's house or down the street, and there was no grid, obviously. So
well, yeah, there probably wasn't a transformer 200 yards down with a big electrode in the ground, you know.
Indeed. But one of my favorite bits in the book, and this is not us making this up, this is literally in the book. This is the last part of the preamble, and it says the chief element of safety, which is brilliant. We love talking safety, is the employment of skilled and experienced electricians to supervise the work. Interesting how they're supervising in the first edition, not necessarily doing. Now, where they got the skilled and experienced from in 1882, God only knows. But it's a really interesting element that was in the first edition. There was a requirements for skills and experience, which we know forms part of competence. And that was in the first edition. Be interesting to see if there's any statistics of people working with electricity that caused harm, and did they ever go to jail? I haven't found any information on that yet, to be honest with you, but there are literally hundreds and hundreds of papers to go through. Right. So moving on, as we know, that's the scan of the original. A few years later, the Society of Telegraph Engineers and of Electricians, they republished it in a 3-page reprint, which is one on the screen, which hopefully everybody can read, because it's nice and clean and tidied up. And so everything we're doing in here today is literally just going through these regulations. There are 21 of them.
And you can actually see quite easily here the layout of the 4 parts. You've got 1 dynamo machine, 2 wires. You can see it all laid out here as to how the parts were done. Do you want me to go through some of these answers for difference between rules and regulations?
Yeah, why not? While we're seeing it, let's go through it. Yeah.
All right. So David says, rules are the guidelines and regulations are the legal acceptance of these guidelines. That's David Graham. Mr. Bickerton says, rules are guidelines and instructions for doing something right. Paul says,
very good.
Regs are you must, shall. Rules are you can, could.
Oh, I like that one, Paul.
Yeah. Sean, rules, individual guidance, regulations, a collection of the above. All the other way around, smiley face. Okay. Another one from Tom. Regulations are supplementary to acts. They link to existing acts, and they are designed to aid a person to apply principles of the primary act. Essentially, they are formal guidelines, and breaching them is not necessarily enforceable in court. And David Betteridge says, laws are also rules that govern everyone equally. Regulations only affect those who deal directly with the agency who is enforcing them. Lots of good answers there.
Yeah, really good answers. Can we screenshot all them? They're excellent answers.
Yeah, they'll be in the comments.
Hang on. Lawrence has said power
Lawrence
of Google.
has done. Power of Google. Lawrence, definition of regulation, a rule or directive made and maintained by an authority such as regulation footwear. Sean says regulations are also said to be maintained by an authority. Okay, and then there's the Google one here. Thanks, Lawrence. Definition of a rule, one of a set of explicit or understood regulations or principles governing conduct or procedure within a particular area or activity. And then Mark for rules says information that must be followed to ensure a safe outcome. Regulations are information to help operators achieve said safe outcome. Okay.
Fair enough.
Yeah,
right.
Great responses.
They are excellent responses. Thank you, everyone. Well, what we'll do is we'll move on. As we've just shown you, there are 4 parts: the dynamo machine, the wires, lamps, and danger to persons.
And remember, as John has already said, this is way back before the grid. This is where you would have to create your own generation source in your large back garden or something, and you'd have to find a way to correctly erect it. And this is, again, it's probably why Earth was an enemy, because you had your own generation source. You didn't utilize the abundance of Earth because you had your own generation source. You know?
Yeah.
So keeping it away from Earth would have been a good idea.
Indeed. Right. Let's begin.
Part 1.
This is an image of one of those large, luxurious, expensive dynamo machines. So in 1882, this is what a dynamo machine was. Most modern youngsters, if they're watching us on YouTube, will know this is a dynamo machine as well. He's a magician. Just trying to put some context. So yeah, dynamo machine, that was part one. The first 6 regulations cover it. Hey, I find it funny.
Yeah, that's great.
So let's take you through these regs. There is no City and Guild exam on this, although I think everyone would pass it with flying colours. I'd love to see Dave do 40 or 80 questions on these regulations. Rule 1, the dynamo machine, or motor as we would lovingly call it today, should be fixed in a dry place.
I mean, it seems short and vague, but it's pretty much to the point, isn't it?
It is.
Especially for people new to the idea of generating or creating their own electrical supply. You know?
Well, that tells me don't go putting it in an outbuilding with no heating and no insulation and where it's damp and there's a leaky roof. That's what it tells me. But people could misinterpret that. You're right. It could be vague. So let's go to regulation 2. It should not be exposed to dust or flyings. I have no idea what flyings actually means. I'm assuming it's flying material or debris.
I'm assuming it's flying material of some respect, yes.
Yeah, but as you can
bear in mind, you've got a big moving thing, haven't you?
Yeah, and what you can see is this is slowly building up to the whole. What you'll see in this is lots of principles that we now know as IP, external influences.
Yeah, but, so Sean is suggesting this might be one of the first ever IP racing requirements.
Yeah, there you go. Sean knows what he's doing. Number 3, and one of my favorites, it should be kept perfectly clean and its bearings well oiled.
It's another one of those words I love, this perfectly.
Can we all, when Amendment 3 comes out of the 19th edition, all go online and comment and say, I want perfectly put in.
Chiefly and perfectly.
Yes.
Chiefly and perfectly.
Enemy danger, chiefly perfectly. Let's get them back into the regs. Let's do a campaign. All 25 of us can sign it and they'll probably ignore it, but there you go. So yeah, it's real common sense. It's very clear, to be perfectly frank. Look after your machine, maintain it, service it. And if you still don't understand that, the insulation of its coils and conductors should be perfect. I mean, this is like, just please don't mess up these motors, because evidently they could go bang and not be great. But our word perfect is in there again. So first edition to me, perfect.
Yeah. Paul says probably referring to things like dusts that are in flour mills and dust factories. Yeah, most likely. These would have been used to as the beginning points of industry at that point. So yeah, it would basically mean put it in its own separate room in your flour factory or whatever you've got.
Yeah, don't have loads of flour and rubbish and wood and logs and stuff sitting up next to it while it's got moving parts getting really hot and a recipe for a fire. But in them days, probably nobody knew what the fire triangle was because it probably didn't exist. It is better when practicable. First use of the word practicable I've seen in any of these documents I've read, to fix it on an insulating bed. Now, insulating term is quite interesting in this, because what we know as insulation and insulating is slightly different. As we'll go through, you'll see exactly what I mean, but we'll come on to some further regs for that. It almost has a double meaning.
Yeah.
But yeah, fix it on an insulating bed. That's fair enough. And then again, one of the greatest regs in here, all conductors in the dynamo room should be firmly supported, fixings, well insulated, fantastic, conveniently arranged for inspection, oh my God, I'm in love with it, and marked or numbered. Hello.
Yeah.
And we wonder why these old installations are damn good. Now, I don't know why that is littered across 7671 with vagueness. That's really clear. I don't know what everyone in the chat thinks, but.
So I mean, look, Tom's got, this is about obviously external influences, cleaners to pay attention when there's slap chemicals and cleaning supplies and switch rooms and stuff. So yeah, need to consider all these other external factors. I like with this, I mean, yeah, you've got here firmly supported. So, we would go down the avenue of suitable erection methods and complicate this significantly these days.
Yes.
But conveniently arranged, for inspection. I don't know if today we make some assumptions on this. No, well, the best example for this is in a fuse board, like mine or Sean's, which are perfect in every way. We conveniently arrange them and we number them. Well, Sean doesn't, I do, but
So, Sean, you're non-compliant with the first edition. No offence.
So Mr. Bruton's pretty much spot on here. He's saying, okay, well, is this what we need to consider today with maintainability? Yeah, we can flip maintainability to clearly point right at this, to say that we need to safely and effectively be able to maintain the system in the future.
So some people are going to hate me saying this, but good comms installers will use a cable comb so that they can arrange all of their looms very, very well, so everything falls exactly into place. And it's an art form. It really is an art form, and it's a skill that's very rarely acquired nowadays, because once you put something in a bit of trunking, it gets tied in knots and all interwoven. And I do remember some people having OCDs about hand laying cables into trunking, and the live, neutral and earth of conductors. I don't know if anyone did this online, but I remember people bunching the circuit together and laying in the trunking. And that they would all be grouped together as circuits, so you could just pull one out really easily, and they're not all interwoven. Of course, it took too long, so they stopped doing it. But
yeah, unfortunately, these days it's a case of once the lidding is on, then they look at the workmanship of the wiring system. Don't necessarily look at the ability to go back in and work and maintain on it.
Yeah, I won't accept any excuses from Sean in the chat, by the way. Let's, John, what's your thoughts on that?
Yeah, I mean, like from the very beginning, it was put in there for, like Paul Brutus says, maintainability. So the whole concept was that what you're putting in today, next week or next month or next year, you can still go in there and make changes or see if it's still in good condition. It was all thought about from the actual outset. Whereas unfortunately these days, a lot of it is just sling it in and who cares what happens after that, because you're obviously gone down the road and done something else. So,
but it's crazy. Like even today, when I deliver 18th edition training, I have to sometimes over explain the importance of maintainability at the design stage. These things like the 2396s and stuff, we could improve these qualifications with a dedicated consideration of maintainability. It seems to be something that we kind of look at, but we don't really program and think in. But it's right here at the very first, the very first edition here.
Yeah, and it should be in there because, I mean, electrical installations aren't magic. They don't just last forever, despite what some homeowners might imagine. They do need to be looked at and checked and inspected and even repaired and altered from time to time. So if it was all done from the start, it'd make it a lot easier for everybody, and it'd make it cheaper as well.
Okay, and who's doing number 2?
Part 2. Okay, I can read some part 2.
Well, that's just an image that was in the book, by the way, guys.
Okay, so number 7. Every switch or commutator used for turning the current on or off should be constructed so that when it is moved and left to itself, it cannot permit of a permanent arc or heating, and its stand should be made of slate, stoneware, or some other incombustible substances.
I love this reg because it's almost a product standard.
Yeah.
Because when you're throwing a switch, you can't allow arcing, which is great. And more importantly, the stand of equipment, because electrical equipment was it got quite hot. When we were talking about insulating or isolating, you had to use a non-combustible surface to fix to, so that you could effectively insulate or isolate the equipment from a combustible surface, which is in, was it 421 or whatever, and all it is nowadays. So it's still very relevant. We were talking about this on our podcast the other day for thatched houses. This is the same. This is section 42 basically. This is
But even today, I mean, we talk a lot about things like the categories of switch gears and testers and showing that they can work with regards to the arcs that can occur in the operation of these devices. But we're only really talking a bit now about things like the heating effects of collected devices, the actual, the duration of any combined numbers of devices. Because back then, obviously, devices were, often in a singular term. But these days, we have so many devices all combined together. And we're still not often thinking about the accumulative heating effect. But even here at the very first, the heating effect of these devices had to be considered as well.
Yeah, slate, when it says slate, that was actually a very common material, because the type of switches we're talking about here were what's called live front switchboard. So it was literally a big slab of slate, holes drilled through it, and then those big brass posts came out, and they had a big handle on the front. And most of the parts were live. So if you didn't know what you're doing and you grabbed all the wrong bits, then you were dead, unfortunately. And it was very important to use the properly insulated handle only, and obviously it would what we would now call by skilled and instructed persons only.
Mm-hmm.
Indeed.
So, Tom Bickerton says, do you remember switches with mercury tubes inside?
Yes, I do.
Yeah.
They're in a lot of hospitals to prevent arcs when you were switching in areas where there were gases and stuff. When I was an apprentice, I worked in a hospital for a while, and we were stripping out all the mercury bottles and selling them to the scrapyards.
Yeah.
We didn't know at the time, obviously, they were a cosh and chip hazard and all that. But one interesting thing as well, just before we move on to the next one, arc. First ever mention of the word arc in the regulations in the first edition. And yet, when the 18th came out, people used to say, oh, arc fault detection. We've never heard that before in the regs. It was in the 17th edition, Amendment 1, and the word arc appears in the first edition. And one of the things that we're finding with this is a lot of stuff that people are saying is new. None of it's new. It's been in the regs in some form or another from day dot.
Yeah, I think something I'll just add to this. We've discussed this a number of times when we've done like podcasts, and we've kind of talked before and after, and we may have even mentioned it on a couple. But the life of the late life of the 15th and the life of the 16th edition, which many of today's electricians were kind of grown on, is heavily, heavily, heavily focused on protecting against electric shock. You know, we brought in over voltage, and a lot of people started looking at each other funny. You know, thermal effects have always been there, but a lot of the study, a lot of the intent has been about protection against electric shock. We've played with earthing arrangements, supplementary bonding, cage bonding, RCD's introduction, all about electric shock. But the whole consideration of heat thermal effects it's never, you know, it's not a new addition. It's always been here. Arc consideration has always been here. It's just a lot of our attention has been on something else, I think.
There's also, there's only so much time and almost so much you can absorb as well.
True.
Number 8, mate.
Number 8. Okay, there should be, in connection with the main circuit, a safety fuse constructed of easily fusible metal, which would be melted if the current attained any undue magnitude and would thus cause the circuit to be broken.
No idea what that's about.
That one kind of speaks for itself, doesn't it?
Well, yeah. First ever mention of fuses, basically protect the circuit. Nothing new. I love the way they, you know, you can see they're experimenting. Have some sort of device that melts away in the event of overcurrent. It's quite nice, and it's very simple English as far as I'm concerned.
Well, it's the original engineering way of protection, isn't it? Again, this is very heavy industry, heavy engineering about fire protection. The utilization of the systems isn't in any way as complex as we get to maybe later on into the editions, catching up to where John's got, where we start to really worry about other types of protection. But a lot of them were there still.
I agree. There we go. Number 9.
Okay, number 9. Every part of the circuit should be so determined that the gauge of wire to be used is properly proportioned to the currents it will have to carry, and changes of circuit from a larger to a smaller conductor should be sufficiently protected with suitable safety fuses, so no portion of the conductor should ever be allowed to attain a temperature that is in excess of 150 degrees Fahrenheit.
Is that in modern money again? It's near enough 70, isn't it?
It's pretty 60 something. Yeah,
it's 66.
Yeah,
very near 70. So almost the same as we've got today.
Pretty much.
That's basic principles, though, isn't it? Now, really, make sure your wire's adequately sized, current carrying capacity.
But it's just aiming at the temperature, and it's not too much about insulation integrity here. It's just about making sure the temperature of the conductor doesn't go above a value.
Well, they were learning, weren't they? So,
yeah.
God bless them. And they managed to fit everything in 21 regs and a note.
But it kind of shows you where maybe insulation was introduced to accommodate that. Let's insulate a conductor, right? Well, it's been designed, or its legacy says it runs at 70 degrees or 150 Fahrenheit. And so they obviously develop insulation materials and tolerances to kind of maintain the status quo in that concept.
So this is the note that follows these. Really relevant, Dave.
All right. These fuses are the very essence of safety. They should always be enclosed in incombustible cases. Even if wires become perceptibly warmed by the ordinary current, it is a proof that they are too small for the work that they have to do, and that they ought to be replaced by larger wires.
Could you argue the same about the fuses? You know what I'm thinking? We've all gone into boards at some point in our lives and used the back of our finger, and we've touched the breakers and gone, they're a bit warm.
Yeah. I mean,
is the breakers working too hard? As you've said in your video, and we've found out from most of the manufacturer now, the thermal effects of not spacing breakers, the thermal dissipation required needed, the grouping factors of breakers that got buried for so long.
Also, let's tie this to what it said at the very beginning about energy efficiency, and let's look at what 60364-81 wants to do, which is allow us to take our cables from an operating temperature of 70 degrees. It wants us to bring those temperatures down by replacing them with larger wires. You know, it's basically coming full circle.
4 mil radials, mate. 4 mil radials. So, it's only a matter of time.
So when we have this coming in, we're going, oh, this is nothing to do with the regs. It says here in the note that we may need to consider if the conductors run warm, increase them so they run cooler.
Yeah. And as Tom said, old fuses and supply cables under the ground, perfectly well cooled, and they can carry a hell of a lot more than they're rated for. The minute they come up into that pitch cutout, and it leaks everywhere because it can't take it. So it's an interesting note. It didn't become a rule or regulation. It was a note. Yeah. So there's lots of advice in this document, which I quite like.
Okay. Number 10. Under ordinary circumstances, complete metallic circuits should be used, and the employment of gas or water pipes as conductors for the purpose of completing a circuit should in no case be allowed.
Can you believe somebody actually thought about doing that, even to write a rule or reg for that? Well, my God, they must have killed a lot of waterboard workers and gas board workers.
They probably tried
it. Have done it. Yeah, somebody must have actually done this, and then obviously there must have been a load of injuries, deaths, and whatever to have, because for this to occur, somebody must have tried it a lot of times.
But again, I mean, we're talking now in modern issues. We've got diverted neutral currents where we may have some copper pipeworks being used as a return neutral current. Maybe we could even return to this and say, oh no, always since then it's been a bad idea to use gas or water pipes to run current through. You know.
Well, if earth is the enemy of the circuit and we earth and bond all the water and gas pipes, in these days it would have been almost heresy.
Would have been, yeah, because you're introducing the potential it's saying we shouldn't have.
Yeah, I know. Doesn't this blow your brain just on what we know about earthing and bonding? But yeah, no. So don't use your gas or water pipes as lives or neutrals. I think that's the lesson there. Number 11, Dave.
Okay. Where bare wire out of doors rests on insulating supports, it should be coated with insulating material, such as India rubber tape or tube, for at least 2 feet on each side of its support.
Yeah. So
a bit of arm's reach maybe or something?
Well, I think me and John have got old books that kind of show a lot of installations in houses where you would have wires run and they'd have like wooden blocks of porcelain. And where it's on the porcelain, it would be insulated so you could tie it correctly and fix it, but then it might be bare for another length of run, effectively. That's part of the experimentation, basically. So Indian rubber or tube for at least 2 feet on each side of the support. So, and that leads into number 12 as well, perfectly into number 12.
Yeah. Bare wires passing over the tops of houses should never be less than 7 feet clear of any part of the roof, and they should invariably be high enough when crossing through thoroughfares to allow fire escapes to pass under them.
How many TT installations I've seen where you've got the overhead wires that are literally sagging,
just kissing it,
and they're just kissing the rooftop tiles, and then eventually there's an instant and they come and they just sleeve it with like this almost plastic horrible thing, rather than fix the problem or try and tension the wires, they just sleeve it. And I know that happens quite a bit in Essex way and the sticks, but
yeah, there's loads around here as well. I mean, you get them half the time, they're not even over the roof, they're just attached to the gutter, and it's just strung across the road to a pole on the other side. So it's actually below the roof level, barely high enough to actually keep the clearance underneath. So
moving on.
Yep. Okay. It is most essential that the joints should be electrically and mechanically perfect. One of the best joints is that shown in the annex sketches. The joint is whipped around with small wire and the whole mechanically united by solder.
And that's an image of it. It would be interesting to see that done nowadays with stranded cables. Whether people could do that.
It's funny. I see like
skill.
I see some of these craft channels and all this stuff do terminations, not maybe exactly like this, but not too dissimilar. And everyone will moan about it and saying it's, but if it's done right, it's done the way it was originally done before. It just, just raise the question of to how its integrity would be today.
Yeah. Do you know what? Would you rather have one of them or a Wago?
Tom says NASA did that. They used that on their space shuttles. Cool.
There you go. I think I'd like to see that. Do you want to shiver?
Yeah,
I would like to see that done.
Yeah.
Be interested to see if we can find any videos on that being done like that.
I've got a document with a load of those shown in it. That's how you actually do them and put them together.
Sounds like a challenge for JW to recreate it. Right.
Okay. The position of wires when underground should be efficiently indicated, and they should be laid down so as to easily be inspected and repaired.
Yeah. So that's just buried services, isn't it? Basically.
Yeah. I mean, it's when underground should be indicated. Yeah. I mean, I like the idea of assuming that even today, service underground should be easily indicated, but it's not always the case.
Yeah, I don't know how you'd easily inspect something that's buried underground, to be honest with you, but repaired, yes. I mean, flagstones, stuff like that. In the olden days when they did, I've got that guide, The History of Cables book behind me. And when they did the old pilk feeders around London, they effectively had them in concrete coffins with lids, so that when you buried it and backfilled and put all the roads over it, once you dug the road up, you could lift that chamber and find that cable easily to inspect and repair it if you needed to. But that was one of the larger ones, which were more valuable, and they didn't want, obviously, the movement of the road over time to destroy it. Smaller ones, yeah, they just put them where they want, really.
Yeah.
Right. Mr. JW, can you take 15 onwards?
Yep. All wires used for indoor purposes should be efficiently insulated. So no bits of bare wire hanging around your living room.
It's about as simple as it gets, really, isn't it? It's outdoor, you can go bare, but when you have a support, it needs to be insulated. When it's inside the house, insulate them, or effectively insulated.
It sounds like common sense, but of course at the time, nobody knew. So
no, henceforth they're rules and regulations.
Yeah, I mean, nobody knew how to kind of live amongst electrical systems back then.
And this was a long explanation. Go for it, John.
Yeah. So when these wires pass through roofs, walls, floors, or partitions, or where they cross or are liable to touch metallic masses like iron girders or pipes, they should be thoroughly protected from abrasion with each other or with the metallic masses by suitable additional covering. And where they're liable to abrasion from any cause or to the depredations of rats or mice, they should be efficiently encased in some hard material. The position of wires when underground should be efficiently indicated, and they should be laid down so as to be easily inspected and repaired.
This is where I'm going to get trolled for saying this, but this is why when I wire in any domestic property, I enclose in conduit. When I go through a wall, I enclose in conduit. If I do anything in an industrial commercial environment, I enclose in a conduit system. In my house, obviously, I've used plastic because I'm more protecting against abrasion, and also ensuring that that big 20mm hole I've drilled, rather than filling it with some goo, it's actually rigid and strong, and I don't get any cracks or anything else. But yeah, this is really basic stuff.
It's basic and it's simple. It's simply explained, and you have it's a simple instruction of the outcome of what you do without telling you specifically how it should be done, which is great. But as long as you have the many options as the ones that you've just described with your conduits going through the wall, that achieves passing cables through walls and protecting them from abrasion.
Yeah, I got a lot of stick for that, but I don't mind getting a lot of stick.
You did, because a lot of people assume that the grey on a twin and earth apparently is perishable. Some people do assume that because you see them run cables through voids. I mean, you run cables through joists, through masonry. It's sharp and it's firm. If you pull cables through and then you don't, pull a loop through, if you just drag it through, you're going to damage that cable.
You got to feed the rats and mice with something.
Yeah, indeed.
Give them a chance.
Going back to one, Tom has said period properties. You can see the lead cloth cables are laid. 60s tower blocks use galvanized conduit wiring systems as well to approach similars.
I did some council tower blocks, and it was all conduit buried in the walls, and it was artwork. Imperial, so it's a bit of a pain in the backside of modern cables to rewire it. But yeah,
here's a question.
Loved it.
It's a question from Paul. Am I right in thinking that when wiring houses, Victorian engineers would use rebated skirting and lay the wires in individual channels?
I don't know about the skirting, but there was definitely a trunking system which was wooden, and it was a piece, and it had individual slots in the top for
Slots in
individual
there, didn't it?
conductors.
I
And
do.
then there's a lid going on. Yeah,
So
David Betcher says there it's wooden trunking. So that was definitely a thing, and it would have been single insulated conductors in the individual slots in the top of it, again keeping them all nice and neat and tidy and in the same alignment.
So Victorian stuff, yeah, I think the cables, a lot of them are either clip direct or put in a wooden boxing. I know in older commercial stuff, I've ripped out box trunking, wooden box trunking oak from railway stations that used to carry the original VIR station wiring from when they were built over 100 years ago and first illuminated. But we do have a video on the E5 Instagram, which was, I think, 1920s, 1930s, of the cable man delivering the lead twin. And it shows the electrician installing the lead twin clipped to the light and up to the socket. And I've been in houses where I've gone to like put sockets and do chasing and stuff, and I've seen bumps in the wallpaper, which look like maybe some sort of architectural groove. And when you actually strip it back to do your chasing, it's a lead twin that's been there and wallpapered over 4 or 5 times. So I have seen that, but yeah, surface, we just go with capping now, unfortunately. Everything's just sling a bit of capping in or oval, and I don't know, not for me, but hey, if individuals do that, that's down to them, but not for me, really. I want to make the next bloke's life better. That's my view on it, because I may be the next bloke. Next one, John.
Right, number 17. Where wires are put out of sight as beneath flooring, they should be thoroughly protected from mechanical injury, and their position should be indicated.
Yes.
Again,
sensible regs.
More sensible. And I'd like to expand this. It says placed out of sight as beneath flooring. I mean, you could even consider like bury cables in the wall. You know, it's out of sight.
Yeah, that's just an example.
When you think about even today with the zones, we have so many posts all the time about, oh, are we in zones? Are we out of zones? The zones are there, but many times we don't hand that indication or that information to the consumer, to the person who's going to utilize the electrical installation. We as electricians have known that the regulations, we said, oh, we've got 150 mil vertical, horizontal, but unless we give that information as an indication, photo, drawing, or whatever, to the people who are going to utilize the electrical system, they can't utilize it safely. And even back then, it says any cables that are out of sight, such as beneath flooring, you know, they need to have protection, but they should also have their positions indicated. So
I remember working in a church in West London, and attached to that church was a flat for the vicar to live in. And I remember we were rewiring that place, and when we went in and we started taking up the floorboards, and I've seen it in about 3 or 4 properties, we would open up the floor and see what can only be described as a work of art under the floor, with a conduit system linked to central junctions around the house, where you would have all the conduits. And I mean, these things were formed immaculately, and the joists notched immaculately. And we were sitting there just admiring it, going, we got to rip all this out.
I know.
And what we were putting in was just to no way or level of a qualitative nature like that. And this is the sort of stuff that required it.
We had the same with the Stewart's house at Ascot Racecourse. I mean, the wiring systems were, you know, there were obviously some additions over time. When it finally needed an overhaul, some of the stuff we ripped out, it was really, it was admirable to look at before you then just yanked it out, and it was quite a waste.
Yeah, you can see where time and cost and money and speed has replaced that workmanlike, perfect terminology that's used in this. It's become this is a nice thing. You have to do it perfectly to just get it in and get on to the next job. And this, I've got a bit of a nostalgia for this sort of stuff.
Yeah, I have. And this is why, I mean, the word perfectly you just said, I mean, how could they even squeeze that in today's industry? You know?
It would cause uproar.
It would.
It would cause uproar.
And of course, at the time, if you wanted electricity, you had to be rich, because all of this would have been horrendously expensive. So 99% of ordinary people would not have been able to afford this. So, of course, if all the money's there, then you could probably actually spend it and actually take the time to do a decent job.
Yeah, you probably do take your time because there probably wasn't a lot of work going for the number of people in the area.
Yeah. So this is a note, and we've got the value of frequently testing the wires. It cannot be too strongly urged. It is an operation, skill in which is easily acquired and applied. The escape of electricity cannot be detected by the sense of smell as can gas, but it can be detected by apparatus far more certain and delicate. Leakage not only means waste, but in the presence of moisture, it means destruction of the conductor and its insulating covering by electric action.
I love that. I want to get a sign made with that.
There's so much information in here. So how many times have we got inspection and testing and in this first edition? Because that's at least the second time testing is mentioned. So you got testing, it talks about skills. I don't know if it's easily acquired and applied. I don't know, maybe they were high hopes for themselves.
Back then, maybe.
Maybe. The escape of electricity cannot be detected. There's a dig at the gas board straight away. But it can be detected by apparatus. So it's talking about test kit, equipment, monitoring equipment, indicating equipment. Leakage means waste. Energy efficiency, again.
Again, yeah.
Presence of moisture, external influence. Mind-blowing. Absolutely mind-blowing how this transposes in 130 odd years. And yeah, there's just something very nice about that. I'm a big fan of these notes.
I think today we've just got so many regulations that the message at the end, or these little regulations, are a big summary of the outcome, and that is lost in so many regulations now.
I agree. So let's move on to lamps.
Lamps.
Mr. JW, you can continue.
Yeah, lamps, and bear in mind that lamps was pretty much the only use for electricity at the time, because there wasn't obviously much else to do with it. So number 18, arc lamps should always be guarded by proper lanterns to prevent danger from falling incandescent pieces of carbon and from ascending sparks. Their globes should be protected with wire netting.
That's fairly evident. When I was a kid, my granny had an old lamp, and over time that would eventually just become very brittle and fall down onto the sideboard that it was on. I think it's warning about lighting, because it's it's about electric lighting. This first edition, it was protecting against the effects of electric lighting. So moving on.
So number 19, the lanterns and all parts which are to be handled should be insulated from the circuit. So you're not grabbing hold of live parts.
Don't kill anybody. So again, almost the first adoption of a product standard for lighting there. Insulate the equipment. Do not kill anybody. Simple, effective, stands out a mile. I mean, everybody watching this, hopefully you're sitting here going, God, this just smacks of simple. Let's go to the last bit.
Part 4, danger to persons.
Yeah, danger to persons. John?
Yeah, so number 20, to secure persons from danger inside buildings, it's essential so to arrange the conductors and fittings that no one can be exposed to the shocks of alternating currents exceeding 60 volts, and there should be never a difference potential of more than 200 volts between any 2 points in the same room.
I'd love to know where they got this from. I am trying to find where this came from in those white papers, but there are thousands. I'd love to know where they got 60 volts from.
Obviously, so this is obviously before we had any network, any harmonized value of voltage and potential differences. But there was something that made them come up with these numbers for everyone's own independent generation.
Yes.
You know? There was something that did that. And we need to dig for that.
Yeah, I will continue looking. I think it's an important one. And also, by the way, these Dynamo machines didn't necessarily give you a consistent 240, 230 volts. They were a little bit lower in them days. Otherwise, they probably would have failed miserably. Right. Next one, John.
Okay. If the difference in potential within any house exceeds 200 volts, whether the source of electricity be external or internal, the house should be provided with outside with a switch so arranged that the supply of electricity can be at once cut off.
So this does suggest anyone approaching the property from outside can hit a switch to remove the source if it's greater than 200 volts inside.
Yeah, and this is pretty much going down the route of a fireman switch.
Yeah, the fireman switch, isn't it?
Yeah.
Which we don't have anymore. be interesting to see when we go into the world of prosumer.
It's a good point you're saying there, Paul, because when we do come to the idea of prosumerism, DC arrays and stuff outside, there's going to be a need for some level of isolation for firefighters, definitely.
And then that's basically it. That's the last part of it. Order of the Council, F.H. Webb, who was the secretary, number 4, the Sanctuary, Westminster, June 21st, 1882. And that is basically our whistle-stop tour through the first edition of the Wire and Regs. I'll leave the copy on the screen. And if anybody's got any questions or anything like that.
There's a couple have come through here. Let me just... when we had the slide on the rules before lamps, so we were looking at the cables and we talked about the testing, and you said it cannot easily be, what was it? It should, a skill in which it is easily acquired and applied, the testing. Somebody talked about EICRs. There we go. Andy says easily applied and acquired. 1 hour EICRs prove this. So I guess that's suggesting that if we were to take the idea of thinking of testing as too easy, we would clearly end up with what we've got with 1 hour EICRs right now. So
yeah, I think it's also worth noting as well that we're talking about prosumerism now, and I think John will agree with me here. When you go through these next editions, you will find the idea of battery storage appears very, very quickly within a very short period of time.
Yeah, it's not a new thing at all. It's been there basically forever. It's a new thing now. People think it is, but of course, in reality, it's not. It's unfortunately, it was there originally, then it went away as things like the National Grid came along, and now we're going back to it because, of course, we know that the grid isn't going to be suitable for everything that we need. It makes more sense to have, if you're generating energy locally, it makes a lot more sense to store it locally and use it than it does to shove it back into the grid and then buy it back later at a higher price. So
yeah. Tom McNulty says, how did they control this frequency? So obviously we had this mention of 60, was it? What's the 60, was it?
Yeah, that was a voltage. Yeah, I mean, if you had your own dynamo in your house, you didn't. It just ran at whatever speed it ran at. But then it didn't really matter because basically you were only powering lighting anyway. So it really didn't make a lot of difference what the frequency was. And of course, you didn't have to synchronize up with anyone else's house because you weren't connected to it. So
that's right.
So individual... the chief indicator would be, does the bulb light up?
Yeah.
You may not get a constant light output, but hey, when you're rich and posh, as long as it's light.
Being a dynamo, you could probably just rank up the actual thing to the output of the voltage that you desire. But there must be some kind of limiter on it so it doesn't go over those voltages.
As you can see, it says a couple of times, testing, inspection. You know, when you're commissioning and bringing this system into use. And let's put it honest, if you were in 1882 and you paid an electrical contractor to come in and fit you a dynamo and all the wires, you'd want to see the lights on and you want to see them working. And that would be down to the electrician to ensure that that does work before he leaves the door.
I wonder what kind of variation of tolerance of frequencies those old incandescents had. Because, you see them where they go dim and then they go bright. I wonder what kind of tolerances they had for frequency.
Probably quite a bit.
Probably quite a high one.
Yeah, I would suggest so. Is there any other questions or thoughts or feelings?
Siemens added here, for Rule 20, the voltages used came from the consortium of fire insurance companies. Main driver of the first 7 editions of the rules was to primarily satisfy the fire insurance sector.
Yeah, there is in future editions, as you can see, the members of the committee is quite short in the first edition, but if you go into the next editions and the next editions, you will see masses of insurance companies, and I think it's fair to say, John, virtually every single one on the planet, and anyone who's got anything to do with fire, all had their tuppence worth.
Yeah, as they go on, it's more and more and more listed in there until you end up with, so like I say, pretty much everybody is in there. The main reason for that was originally all these insurance companies had their own rules originally, which of course was hugely confusing because depending on who insured the property, the rules to put stuff in could be totally different. And then eventually they all started consolidating together until eventually you got like, we're going to have one set of rules for everybody rather than every company has their own individual set and basically confuses everybody.
It's fair play to say as well, the Americans, when you read some of these papers, the Americans took this and they adapted and adopted and improvised and tailored it to their needs. And some of the old books I've got are on American electrical installations, John. And I think it's fair to say they went full on. I mean, they literally went full on with electrical installation. Some of the books that have been published for America, state by state, nationally, are off the charts with some of the stuff that are in their books and the information. And so America, you know, they took this to heart, because the original society, before it was the IEE, the original society was about consolidation, talking about different electrical experiments in Mexico or Chile or Africa or Norway or whatever, you know, and telegraph cables under the sea and all that sort of experimentation that went on. This is where people spoke about their experiences and shared their knowledge, and that transferred across to the States as well, which we could be here for hours talking about the impact of the regs in America and how they went off on their journey. But we thought we'd just try and keep this first one lean, just to the first edition and the footsteps that we went on. The one thing I did forget to say, and I apologize for it, is the Electrical Lighting Clauses Act, which was a law, and then obviously this first wiring rules came out in the same year. That Electrical Lighting Clauses Act went on to eventually become the Electricity Supply Regulations, which then went on to become ESQCR. So Electrical Supply Quality Continuity Regs that we have now. So there is quite a linear look back at some of this legislation, and it's all, again, freely available to download. Any other questions? Or is this going to be the shortest one ever?
This is nice and short. Dex says, can we have follow-up webinars, key changes by edition? So
yes, get writing them, Dex.
Yes.
We've got all the editions looking through. One per, we'll have to identify what the key changes were, but we'll do something that shows the key shifts or the actual main key gear changes in the way that we just evolve the way we're doing things today. But when you look at this, original standard, there's such a little bit of information here, but the actual the intent and the actual outcome is fairly obvious. And when you end up reading 7671 and you end up getting in that minefield of understanding one regulation from the next, and this is like I do on the 18th editions, I always try to go through a bit of technical, but then I always try to come back out of the book and generalize and summarize what this book is trying to do. I mean, this is why, Paul, you'll always reference chapter 13, because the fundamental principles, because if we haven't hit that, then it's flopped. And one of the good things about going back and reading this is it allows us to just understand in the simplest term what the outcome was. So that when we go back to the regulations that we have today, we need to also carry this on. Sorry, hang on. Oh, I'm in a thing. So we can also carry this on, and we can generalize it, simplify it. And the more we do that, the more we can use the regulations today by keeping it simple.
Yeah, I think we've lost some of that. To answer your question, Dex, yes, but let's get on to it. Before we end this, should we talk about webinars?
Yeah.
So we've got another one in 2 weeks, and it's chapter 13 versus electricity at work regs. Now, in theory, it's not long. It's probably 2 hours. However, I'm genuinely thinking we might want to split it up over 2 days. So I'd like to ask the consensus of everyone. Do you want to do this over 2 nights rather than doing one mega 3-odd hour one? Because this one's going to be really interactive, because we're going to go through all 53 or 54 regs in chapter 13 and then debate where they fit into the electricity at work regs. Because as Dave said, this is how I learnt it, and this is why I keep going back to it.
It's
so
probably a good idea.
Audience. I think 2 nights.
Lawrence says split, Terry says split, Dave says split, Anne says split, Tom says split, Dave says split, plus the split. I get that. I get. Yeah, I think I agree, because we'll get to a point where we're 2.5, 3 hours in, and we're not even like getting through the point, and we may end up getting to the point, if we try and do it in one hit, where we're going to have to just cut things off and rush things, and that's a waste opportunity to properly get that message across of challenging 7671 to the EAWR. Okay, well, what we'll do is we'll keep the schedule for 2 weeks' time for the first part, and we'll see where we get to, and then we'll resume maybe a week later or so.
Well, I was thinking it might be easier for everyone if we did it over 2 nights, just one after the other.
Well, I'll have to look what I'm doing the next night.
We'll just do it without you. No, I'm joking. We can't do it without you.
Me.
We can't do it without you. Don't be silly. So we have other webinars planned.
Okay, I will look at my calendar, and tonight we will look at the second date and we'll put it on the website to open for registration.
Cool, great.
We'll do that.
So we have other ones planned. We have the Irish regs versus the UK regs, which is going to be hysterical. That is not going to be a two-nighter.
No,
there is lots of changes. We have other stuff that we're still researching.
Yes, we have. If you want to ask us questions about EV, we're still researching. If you want to ask us questions about RCDs, we're still researching. We don't rush answers out because there's a lot to learn and to get out of that. Even prosumerism, even battery storage. We've got a couple of experts we want to try to challenge their brains on, and we learn a lot just as much, and then we put together some stuff and then we share it as a group. It might take a bit of time, but we're not trying to rush all these out. Lawrence says, where can I get hold of edition 1, please?
Can't say.
You can either spend your rest of your life searching for it in old bookshops and probably pay £1 billion for it. It was reprinted in a book, and I can't remember the name of the book, but it was about 15, 20 years ago, I think. So what's on the screen now was actually reprinted in a book, which the IIT did actually publish. So if you can find that book, then it's in there. And they actually put a couple of the other editions in it as well, as a sort of assembled sort of reprint of several of the old ones. So
yeah,
it did exist.
Just to answer Lawrence, I have suggested to the IIT that they republish in a book editions 1 to 5, 6 to 10, 11 to 15 as historical documents for Sparks, or make it available as part of the IIT Gold subscription. I think people would buy it because it's still very relevant. And also, I'm gonna give you an example here. There was, I think I mentioned this when we were talking the other day, and I can't name names or anything like that, but there was an example where there was a court case of an electrician, and there was an incident where the electrician was being prosecuted for an accident, a shock. And the electricians was debating the quality and technical compliance of the work, and a comment was made about the age of the installation, and he said that fuses weren't a requirement until much later in the regs. And the first edition was quoted to a judge in a court of law as requiring fuses. This electrician looked and felt very, very stupid. And that is about all I can say about that case. So just be wary of this sort of stuff. A lot of people dismiss this as rubbish. It's not. This is a book or a document that was published, which if you try and say, oh, we don't need to worry about RCDs, they weren't in an early edition of reg. Really? They've been in it for they've been around for 20, 30 odd years. So you can't say that. Even AFDDs, when they came out, everyone was surprised, but they were referenced in the 17th edition.
Indeed. And it's important to remember that when we do introduce new technologies, even like these old VOE LCBs, everything else adjusts to incorporate new technologies. And if we decide to disregard one thing, everything else has also been adjusted to accommodate that thing. We've got this potential in Amendment 2 where we might look at getting rid of protective conductor currents because we're going to start, or the regulations about them, because they work at 10 milliamps, where we may have to achieve 9 milliamps every circuit. So one thing changes another. And so we can't just pick out which ones we want to pick out and ignore.
And this is one of the problems we're finding. So one of the reasons why we're being probably a little bit secretive is when we do this, we do get lots of comments and engagement, some of them negative, some positive, but we have to be very careful as to the level and extent of research we're doing. So I'll give you a heads up. We are writing to every single one of the manufacturers we can write to, asking the same set of questions. Once we have that and we discuss it in our podcast webinars, we will make that available on a spreadsheet to people. But we are researching stuff. I think it's fair to say with the more complexity of the technology and the demands of energy and government and manufacturers, there is something missing. And this is what we're trying to research so that we can have that debate.
It's important to add that not every manufacturer gives us the same response.
Yes, they tell us to, some of them very politely put some fingers in the air at us, but that's also fine.
Yeah. Even their approaches are slightly different, which means we have to then compare.
You can only make assumptions based on the facts, but we do have stuff. Hopefully we'll have some interesting stuff for you. Some of this we've never really spoken about in this level of detail either.
Yeah.
So,
and if you watch the previous webinars where we covered earthing and bonding and stuff, we threw in some other little things, diverted neutral currents, phenolic degradation and all this stuff. All this stuff we're going to talk about more probably in December time.
Yeah, sorry, it's not as many as before, but it takes ages to try and work full time and do all this.
Yeah.
And anybody from Discord who knows, we are always constantly researching every weekend and most evenings. So we'll get around to it. And by the way, the guys don't want to do a podcast in a hot tub, I asked, so that's off the table.
All right, I'm going to just scan through. If there's any other little questions I've missed,
there is one. There's one that someone said, could someone still find a dwelling wired to this regulation as old as this? I'm going to say no.
To this. Only if it's been like lost in time in a forest.
Well, I think sometimes you will find installations where the original wiring is just left, cut and then left. I think Sean brought some cable to my house the other day with some of these joints on it that he removed from an old house. I've seen installations where I've gone in, done wiring, and I've seen the previous wiring and the previous wiring because the sparks would just cut it and leave it under the bloody floors.
Yeah. There are probably big manor houses where there's like a wing or an area that's been cut off or ignored or abandoned, where one day an electrician will just come upon it and open it up and find this marvel in front of them, which is actually to this old standard. But yeah, rare.
Yeah, and bear in mind the second edition came out only 6 years later, so it's a very narrow window of opportunity.
Very narrow window.
Still exist.
If you do, hopefully there'll be a copy of the regs next to it. Then you'll be lucky.
Indeed. And is there anything else, Dave, or is that it? Can we thank everybody for coming and let them enjoy their evenings?
I think we're done. I think everyone, thank you for coming in. As we did with our third, it's one of the reasons we like doing these webinars is the extra interaction we get live with you guys. Obviously, I'm going to put this up on YouTube. People on YouTube, you can add comments and you can ask questions. We will get back to them. But it's so nice having some of you guys add your opinions and your responses as we go. So yeah, I do enjoy doing these. Hey everyone, thank you for coming in. Thank you, and thank you, Paul. I'll just say this presentation was thrown together by Mr. Meenan. You can probably tell by the Dynamo joke. It was thrown in. You actually had this one ready a long time ago.
This was done. This has been done for about 9 months. This one.
Yeah, this one has. But
so we are ready to go.
We are working on others, but we decided not to start doing webinars until we were in that working flow.
Yeah, I am not. Sorry, guys. I'm not going to rush any of these.
Yeah.
They've got to be ready. And we did that with the last ones when we did the coding. They were very rushed and it was very stressful. And I don't want to do that anymore. So these are slightly different with more quality of research. So they'll come as and when.
Yeah, but thank you everyone for coming in. Tom, thank you for the podcast. Very interesting, informative. Dave says Bristol's the only place I found working old cables in wooden trunking about 10 years ago. Tom says Buckingham Palace. Yeah. Okay, cool.
Thank you, everybody.
All right, everyone's just saying thank you. Awesome, guys. Thank you for coming in. Our next one is 2 weeks. 2 weeks. It's on the website and you can register for it now. And I'll also later tonight put up the second half of it. We will do a little adjustment. I'll put that one up later tonight as well. Otherwise, if we see you in the Discord or any other social media, say hello on YouTube. Let us know what you think. Let us know if you'd like us to consider any other subjects. We'll put, our time is limited, but if things are interesting enough, it's inherently in our nature to find stuff out and dig into these. I'll hand over to John and Paul to say goodbye. Paul's actually in charge of the kill switch tonight. So
I'm just still trying to find the kill switch.
It's just one last thing. Someone did ask how much it cost, the first edition. It wasn't actually priced. The second edition wasn't priced either. The first one had a price, was actually the third, which was sixpence, which was in 1897. Which was quite a lot actually in 1897. It wasn't sort of just throwaway money. It was.
Let's not start a debate on the cost.
Moderate so sixpence, and the others didn't have a price, but probably wasn't going to be too far out. Inflation wasn't particularly high in those days, so.
And hopefully we'll get this on YouTube this week, possibly.
Okay. Cheers, guys.
Peace, everyone. Bye-bye.
Bye.
Bye.
You found the
Switch
switch.
this off.
I think you've just done it, I think.
Have I?
Yeah. Well, we're still here, but I don't know.
Are we still broadcasting?
Probably.
Oh, I need to learn these more softwares more. Okay, got it. Right, bye, everyone.